Howdy, howdy, this is Mr. Potter. With our discussions about recursion in this past week, I think it's time to start talking about how we can use this recursion in some more advanced techniques. So one of the things I want to talk about is a concept of a merge sort. So what I'm going to do is I'm going to type up a list of numbers. So I've got the numbers 1, 4, 7, 2, 5, 8, 3, and 6. And I want to put these numbers in order. One way that I could do it is I could say, you know what? If the first half of this list was in order and the second half of this list was in order, then all I'd have to do is go through each list, and whichever one is smaller, I would put it first. So that's something that I can do. So in other words, if I can get this first half of the list sorted and the second half of the list sorted, then I can just merge the two lists together. But in order to sort this list, I would have to break it apart into two halves as well. And if this first half was sorted and the second half was sorted, then I'd have it done. So I'm going to look at this first half of the list. If I broke this list in half and the first half was sorted and the second half was sorted, I'd be done. But the thing is, a list with that one element is already sorted. So this list that only contains a 1 is sorted. And this list here that contains a 4 is sorted. So what I need to do now is I need to kind of copy them to a temporary list, so a 1 and a 4 in order, and then put them back in my original list, and I know that this 1 and this 4 are now in order. So now I need to make sure I can sort this list here, because this was it. If I had the first half sorted and I had the second half sorted, then I just had to merge them together. So I'm looking at this and I'm going to break it apart into two lists. So this 7 is sorted and this 2 is sorted because they're each one element lists. Which one comes first? The 2 comes first. So over here I would put a 2 in this position, and that means that I would put the 7 in this position. And then I would go up here and just 2, 7. And now this part of my list is sorted, and this part of my list is sorted, and this part of my list is sorted. So all I would need to do is merge them together and I'd be good. So let's go ahead and talk about merging these together. So of these two lists, which one comes first? Well, the 1 comes first. And then of the 4 and the 2 would come first. And then of the 4 and the 7, the 4 would come first. And then the 7 is a list by itself, so it would have to come first next. So what happens is the act of this breaking apart and merging, I've already sorted the first half of the list. So now I need to sort the second half of the list. So again, this 4 elements here, if I were to break this up into two lists, and this first part was sorted and the second part was sorted, then I would just have to merge them together. Well, this is a 2-element list, so if I broke it apart into two lists, made sure that was sorted, made sure that was sorted, then I would just merge them together. But you know what? This 5 is already sorted, as is this 8, and if I merge them together, the 5 comes first and the 8 comes next. So this 5, 8 is in order. So now I just need to merge this part of my list, the 3 and the 6, make sure that they're in proper order. But 3 is a singleton and it comes before 6, so this would just be a 3, 6. And now I need to merge these together. So of this list and this list, the 3 comes before the 5, so a 3 would come first. So now I need to merge these two lists. Between the 5 and the 6, the 5 would come first. Then between these two lists, the 6 would come first. And then between, well, there's only one item left, so the 8 would have to come now. So this list becomes 3, 5, 6, 8. I copy it back to my original list. So now I've got the first half of this list is sorted, and the second half of this list is sorted. So now all I need to do is I need to go through and figure out who is the lowest. Well, 1 is lower than 3, so we're going to start with a 1. Then 2 is less than 3, so we're going to do a 2 next. Then 3 is less than 4, so we're going to do a 3 next. Then 4 is less than 5, so we put the 4 next. Then the 5 is less than 7. Then the 6 is less than 7. And the 7 is less than 8. And then I have a list that just contains an 8, so that must be in my unique spot. So I copy these back to my original list. So this is 1, 2, 3, 4, 5, 6, 7, 8. And this original list is now sorted. So this divide and conquer, where if I sort the first half of the list and then sort the second half of the list and then merge the two results together, that's going to get me a sorted list. And my base case were these situations where I had a list with one element. A list with one element is sorted, so I need to do nothing. So that's the idea here. So what we're going to do is we're going to create a class called MergeSort. So public class MergeSort. And I'm going to create some methods in here. So the main idea is I want to get my recursion in here. So the recursion. So I'm going to have public static void MergeSort. And in this, I need to keep track of my original list of data. I'm going to also need to keep track of a temporary list of data, this place that I'm going to be copying the numbers to. I'm going to need to know where the start point of the list is and the end point. So the thing is, for example, when I was sorting the second half of the list, I was actually starting at position 4, ending at position 7. When I was sorting the first half of that list, I was starting at position 4 and ending at position 5. So for each level of recursion, I need to keep track of the starting point and the ending point. So what we're going to do is if the start is less than finish, then I want to sort the first half of the list. Now, sorting the first half of the list, I need to find where a halfway point is. So int mid gets start plus finish divided by 2. And this is the part that's actually getting me to my base case. The idea is that when I divide an integer by 2, it's just the integer quotient. There is no remainder. There is no decimal. So if I want to sort the list that starts at 4 and ends at 5, 4 plus 5 is 9, so I have a list that goes from 4 to 4, and that will not trigger this. So my base case is to do nothing. My recursive case is sort the first half, sort the second half, and then merge the results. So we're going to just write this down, and we'll talk about how to do it later. So I want to sort the first half of the list. Now, I'm still giving it the list. I still have my temporary array. What's different is because I'm doing the first half of the list, I'm going to start at the beginning, but I'm not going to end at the end. I'm only going to end halfway, at mid. And then if I want to sort the next part of the list, MergeSort, I still need to tell it the list. I still need to give it the temporary array. But I'm going to be starting after the middle. So this would really be mid plus 1. And then the end is the last place that I sort. And then finally, I need to merge the lists. So I'm going to be merging the lists. I need to know what the list is, what the temp is, what the start is, and what the end is. Because I can always recalculate the middle if I need to. It's not a parameter that I need to pass on. And that's it. We're done with the MergeSort method. The thing is, this gets us to our base case. So what we do is we sort the first half. We sort the second half. And we merge the results together. So I'm done with MergeSort, because MergeSort is this divide and conquer technique. The hard part is the actual merging together. That's what we need to do next, the hard part. We need to do public static void merge. And to merge, I'm going to have an int array called list. I'm going to have an int array called temp. I'm going to have my starting position, and my ending position. And to do this, let me go ahead and lower this down a bit so I have some room to code. To do this, I need to keep track of several things. First, my mid, which is start plus finish divided by 2. I could have passed this as a parameter, but it really is kind of taking care of itself here. And I'm also going to need to keep track of 2 iterators. One is going to track the front half of the list and see if it's the lowest, and the other one's going to be tracking the second half of the list, seeing if it's the lowest. So I'm going to do int head1, which is going to start at start, and head2, which is going to start at mid plus 1. And then what I'm going to do is I'm going to go through each list seeing who is the lowest. But I want to keep doing this as long as head is less than or equal to mid and head 2 is less than or equal to end. Because as long as there's stuff in both lists, I have to compare both lists. If there's ever stuff that's just in one list or the other list, then I just finish copying it over. If I only have one list with data in it, I just copy those elements point by point. There's one other variable that I need up here, though. I need to keep track of where I'm going to be copying stuff into my temp array. So I'm going to have an int spot, which is going to start at the beginning. So here's where we're merging. The first thing I need to do is I need to see which list has the smallest element. So if list sub head 1 is less than list sub head 2, if that's true, then the first list has the smallest element. So then I want to copy that element over. So I want to say temp sub spot is going to get list sub head 1. And the thing is, I'm done with that spot, so I need to move spot up. But I also need to move head 1 up because I've already copied that data out of that spot. So I copy from my list into my temporary array, and then I increment both the place in my temporary array and the place in my original list. Now, if that's not true, the second list has the smallest element. So I need to say temp sub spot is going to get list sub head 2, and spot plus plus, and head 2 plus plus. So this is the same idea, it's just I'm going to be copying elements from the second half of my list. So if I get out of this while loop, one list must be empty. In other words, I'm at the end of one list. So I need to copy from whichever list is remaining. And at this point, I have no idea which list is remaining. So what I can do is I can just say, hey, let's just go through each list and add it to the remaining list. So I could say while head 1 is less than or equal to mid, then I'm just going to go ahead and do the same thing I did. Temp sub spot is going to get list sub head 1, and spot plus plus, and head 1 plus plus. And then while head 2 is less than or equal to end, then temp sub spot is going to get list sub head 2, and spot plus plus, and head 2 plus plus. So at this point, I've got everything in order, but it's in order in my temporary directory. So what I need to do now is I need to go back and copy everything from my temporary directory back to my original list, starting at start and ending at end. And that's why I didn't want to touch those variables. I created new variables, head 1 and head 2. So I'm going to say for int I gets 0, I is less than, actually I don't want to start at 0, I want to start at start. I is less than or equal to end I plus plus. And then I'm going to say that list sub I gets temp sub I. So what I'm doing now is I'm copying back from my temporary array into my original array. And this is the hard part. This merge method is the hard part, because I have to keep track of these things and put them back in the right order. First, making sure my list is in order, and then second, that it's back in my original list array, not in this temporary array. The whole purpose of this temporary array is just to hold stuff for me. So at this point, let me compile it, make sure I don't have any egregious errors. Anything bad in here? Yeah, too many braces. That happens with this autocomplete thing. So that should close merge, and that should close my class. So that looks good. So now can't find symbol. Oh, finish. I should call it end, just to be consistent. End. And then one more. End. Silliness. Okay. So now I've got a working merge sort as long as I have a list and a temporary list in the start and a finish. I don't know about you, but if I just want my computer to sort a list, I just want to hand it a list to say, just sort it, just get it out of my hands. So I'm going to overload this method here. So we're going to have an overloaded recursion. And so this is going to be the public call. So basically what I'm expecting is if I'm a user, MergeSort, all I really expect to do is to say, here's my list, deal with it. And so here's my list, deal with it, okay. I still need to come up with a temporary array, and it should be as big as my list. So int array list gets new int sub list.length. So I create a new array. It's got to be the same array length as my original list. I'm going to start at the beginning, and the beginning of my list is 0. And I'm going to go on to the end of my list, and the end of my list is list.length minus 1. So I'm going to say MergeSort with the list. Actually, I probably shouldn't call this list. I should call it temp. So with my list, with my temp, starting at position 0 and going to the end, which would be list.length minus 1. Now, this is my public call, which means I really want this to be private. I don't want the user to have to worry about the details of coming up with a proper temporary array and coming up with a proper start and finish. They might muck it up. So I'm going to make this private, and I'm also going to make merge private. And so what's going to be convenient is that I'm just going to have this static merge sort method. If I'm given some int array, then it's going to be very easy to just call it up. So all I want to do at this point is just call on MergeSort with some array. So public static void main string args. And so I'm just going to create a array. So int array list gets new int, let's put 100 numbers in it. And then for int I gets 0, I is less than list.length, I plus plus. And we're just going to stuff random numbers in it. So list sub I is going to get, and I'm going to call on math.random. I'm going to multiply it by 1,000, I guess, sounds good. And then we'll go ahead and cast this as an int. And then just to keep us our sanity, I'm actually going to call on arrays.toString. Remember we talked about the arrays class a while back, and the toString method basically prints out an array in a nice form. Of course, I have to import that. So import java.util.arrays, just to keep us honest. I could write another loop that would print this out, but I don't want to deal with that right now. The important part is the idea of calling upon MergeSort, which I'm going to do right now. MergeSort with my list. And then I'm going to systemoutprintln arrays.toString again. So let's compile it, make sure nothing's horrible in here. Looks good. If I run it, notice that I'm using the public call of MergeSort, where all I have to do is pass it a list. I'm using this overloaded call, which only has one parameter, and not this private call, which has 4 different parameters. So if we run it, so notice that I have a list here, 224, 380, 724, 177, 696, 18, out of order. But after I print it again, I've got 4, 18, 18, 24, 100, 120, 122, 129, all the way up to 995. This list definitely looks like it's in order. And this is a recursive call, so it actually ends up taking a little bit less time to do all of the swaps, because it only does a swap when it's actually comparing one on one element to one element, not an entire array with another entire array. And so this is the first of the recursive sorts that we're going to be talking about in this class, to just give us a basic idea of how to take care of a situation like this. There's a couple of things in here that I did just to clean things up. I did public methods here because I want my user to use this method. I do not want my user to deal with this method, and I certainly don't want my user to deal with this merge method, which is a monstrosity. It's very ugly. But, I mean, this takes care of just making sure the list is in order, and as we've seen before, recursive code tends to be very short. All I'm doing is I'm calling on myself twice, once for the first half of the list, once for the second half of the list, and then just smush everything together. But smush it in such a way that they end up in order. That's why we have these 3 while loops down here. So we're going to continue talking about this recursive sorting technique as we go on through the week. So once again, this is Mr. Potter. Thank you for watching. Have a great day.